I will explain a few concepts that will be also important, a bit shortened down because we have no time. Some table and annotation processing capabilities, because these are quite important when you want to collect your results and when you want to modify whatever annotations and metadata is available on the data. And JIPipe has there many different nodes. So far, we use annotations only for distinguishing data, where annotations that start with a hash are deemed as important for determining if they are in the same batch for the batch processing. But you can also absolutely use it for creating branching pathways, merging data together, and other things. So far, for example, we had statistics that were generated, but they were individual, one per image. But it is often that you need one table with everything. You need the ability to create some summary tables, and often you need to also create plots. And the same system allows you to adapt the behavior of algorithms to data. For example, change parameters interactively or change the parameters based on metadata that is available. So these things are all very well connected to each other, and there are many nodes there, so you have a lot of control. I have an overview of these, what you can do with JIPipe's annotation processing nodes. For example, you can set and edit annotations manually with a node. You can filter data out with that. There are also other variants, for example, an if-else like filter where you can branch data into two paths. You can rename annotations to set the name if there are some changes that you need to make, and of course you can delete them. Annotations are also useful when you extract them correctly. So there are dedicated nodes and functions that help you with the extraction of annotations from metadata like file names and other things. And one of the main nodes of that is this set edit annotations node, because there you can tell the node, create an annotation with that name and that value. And there you have the full capabilities of the expression system to really do some processing afterwards. I will explain in a minute what one of these looks like. You can add multiple into a list in this node, and then you can basically set the name of the annotation to create for this data that it's currently processing. It will overwrite items, and then also the value it will generate for that. This is one of those that I've shown you here. This is one of these expressions. There's actually a quite logical language. You just have to get used to it. It's very similar to how Excel does its expressions. This here is basically a method that takes the current value of hash data set. The hash is included in the variable name. That's why it's colored orange, and splits it by an underscore. And then it will take the first one. This is what this add thing does at 0. There's also an explanation what each individual thing does. In our example here, if the data set is D15 or underscore 1, it would split it into D15 and 1, and then we would take the first item of that, which is then D15. So this is then the output of that. You just have to get used to it, but it will be very powerful. And these expressions are also very useful for table processing, because JIPipe has there many. This extractory statistics, it is basically a node where you can manually extract statistics from a region of interest, like the particle finder, but you can tell it on which image. And this would measure out the ROI. And then to process these, you can, for example, go through each row and then apply an expression there to calculate a new value. You can also summarize tables with another node. And you can do some more advanced operations like applying something on whole columns, merging multiple tables into one. This is an important one that you will use actually, and creating plots. So you just can refer to this overview, what these nodes do. So now about ROI processing. So ROI processing is also very useful and powerful. And JIPipe has there many functions available. And also you have some more advanced things about parameters that I will not show to you. But what is important is here also this label processing, that you know that it's there. So, so far we used only ROIs and the simple filtering from fine particles 2D, which has this basic image thing, a size filter and a filter for circularity. But you know this is not enough. You need something more complex. You have usually more interesting conditions than these two. And this is why JIPipe has many different ROI-based processing operations. So you have basic ones that, for example, say, okay, I remove all ROIs and the borders. It needs an image. As to say, see here, it has an image input because the ROIs are just outlines. It doesn't have any information about its source image. Then here's a very important one, filter ROI by statistics, where you can do something like fine particles 2D, but more powerful. Then outline ROI. This would basically create bounding boxes, convex hulls, and other things about ROIs. Just browse through the options. They are very useful ones. And then the one that I mentioned before, extract ROI statistics, where you can manually extract the statistics of a ROI over an image. This image is optional. If you don't give it an image, then it will make a black one and then do it on that. And this way you can manually measure out ROIs. For example, if you filtered them and you want to really get now out the measurements, use extract ROI statistics or extract 2D ROI statistics. Some of them are a bit renamed with that. And this is what you will encounter, especially with the ROI nodes. They have often optional inputs. They are identified by this gray text. This means they take optionally an image. If you don't give it, it will usually generate something automatically. And in the case of ROIs, it will generate a black image in the background for you if you don't give it one. So for example, this one, I want to show you how to do some more advanced filtering. And I have here a little outline of a pipeline. Instead of having the filter in fine particles 2D, if you leave it alone and don't change anything there, you can also use filter ROI by statistics. And there you have a setting where you can define your own conditions. For example, this one here, where I want that each ROI's circularity shall be larger than 70%, and at the same time, the mean value within the ROI, the mean intensity, it should be larger than the median of all the mean values. So this way you can make really complex ones that also involve information from outside. You can introduce measurements into the annotations that will be available. You can use global variables and other things in these expressions. And for that, I really recommend, if you're not familiar with these, use the expression builder, click edit. It's one click. You find a list of everything here on the right-hand side, what is available, as much as JIPipe can provide you. You can edit it. It will check it for you if it's valid what you typed in, and you have a help here in what you can type in, how this general language is built up. There's also online documentation that explains it a bit further, but you then go to the website. So about these advanced parameters, I skipped them because they allow a lot of flexibility for you, but you can read up about this if you're interested. You can adapt parameters to annotations and change them live, basically. And you have also the ability to add external parameters to nodes, where you can give it external parameters. This way you would make multiple parameter sets. So this I can't show. But label processing is important because image JROIs are contours, as mentioned yesterday. I have an example here, also provided somewhere in these directories, where the ROI method from ImageJ absolutely fails. So I used here a contour filter and then get out image that looks like that. If you apply fine particles 2D on that, or ImageJ's particle finder, because they behave the same, you will get something like that out, where the holes are filled in. You can tell ImageJ to please keep the holes, but this is not always successful, and they cause weird issues later down the line and you make statistics. So I would not recommend this. So instead, you want to use a label-based representation where each component of the image has its own label. And yesterday I showed you the nodes for that. You can use the connected components labeling 2D algorithm for it. And there you find equivalent algorithms that handle labels but behave the same approximately as the raw ones. For example, you can render them out, you can visualize them, and others. There are some more advanced features in JIPipe that help you. This montages thing I already showed you yesterday how to do this live, so we can skip it. Then JIPipe can also annotate data to data. So you will encounter this if you're using mostly something that trains deep learning algorithms, because these need data annotations. And they are distinct from the text annotation. You see it with the label icon. This one is like this tag, and then these get another icon. And they are important when you are starting using cell pose more and then train your own models. There are different nodes to process them. And also something that you should know that it exists is runtime partitions. They are a very advanced feature. What they do is they're basically separating the pipeline into functional units, but not visually like the compartments, but runtime-wise. So they're basically handled in a different way that allows you to loop over specific parts of the pipeline. Because in JIPipe, you have maybe noticed it where when you load all the input files, then when you run a node, it basically runs this whole node, and then it runs a whole node after that, then it runs the whole node after that, and then so on. And what you usually want to do for if you have a lot of data is you basically want to loop a part per file, for example, repeat this part so you don't load all images at once. And this partition system is just there. You can read about it online when you want to use it to loop something over files. Just need to know that it exists. Not everyone uses it all the time. It's a bit complex, and then at some point it will be solved with an update in JIPipe.